Another shortcut to take derivatives is called the quotient rule. This is a listening check. Underline quotient rule. Alright, the order matters when you're taking the quotient rule. So what it says is the derivative of f over g, because that's a quotient, is going to be bottom function, in this case g, times the derivative of the top function, which is in this case f, minus the derivative of the bottom function g prime times the top function all over g squared. This is why you remember it. Low d high minus high d low over low squared. Low d high minus high d low over low squared. There's a song to it. Google it on YouTube so you can learn it, because you need to know it. So again, we're going to say what this means. The bottom function times the derivative of the top function, low d high, so low derivative of high, low times the derivative of high, minus, so then subtract the top function, because it says high, high d low, so high, which is the top function, times the derivative of the low function, so times the derivative of the bottom, all over the bottom function squared. So low d high minus high d low over low squared. Low d high minus high d low over low squared. Have to memorize it. Have to memorize it. Have to memorize it. Have to memorize it. Am I saying it enough? Have to memorize it. Remember this. Remember this. This is a listening check. Shade in Q in quotient. Shade in the Q in quotient. So let's take a look at an example. Alright, so label it high and low. So the top function is high, the low is low. So it goes low d high. So 4 minus x is low, times the derivative of the high, which is 6x squared, minus high d low, which is the top function, which is 2x cubed, times the derivative of the low, which is negative 1. All over the bottom squared, low squared. So 4 minus x squared. Missed a step. So step 4, simplify and combine like terms. Those going to be the last step. Alright, so let's clean this up a little bit. Let's get in the house. So we're going to get 6 times 4 is 24x squared minus 6x cubed minus, oh, it's going to make it a positive, isn't it? Okay, I'm just going to leave it in parentheses. Negative 2x cubed all over the bottom function squared. I'm not going to square it out right now because I don't know if I need to. Alright, so that simplifies to 24x squared and a 6x cubed. Those two negatives becomes plus, so negative 6 plus 2 is negative 4, so that's a listening check, negative 4x cubed. We can factor 2x squared from the top, leaving 12 minus x all over 4 minus x all squared, and I can see nothing simplifies, so that's it. Let's take a look at one other example. I'm going to make it a little bit more complicated this time. Let's put some fractions into it. So let's rewrite this with the fifth root on the denominator as a power. So that's going to be x to the power of 1/5, so that it makes it easier to take the derivative. Alright, label low and high so that you know which one's which. Alright, so then taking the derivative, low d high. So the low thing, which is x to the 1/5 times the derivative of the high. We're going to do it on the side just in case it gets messy. So derivative of the high is 7/5 x, then 7/5 minus 1. And to make the denominator minus 8/5 x 8/5 minus 1. The denominator is the same, times 5 times 5 on this one, times 5 times 5. So that's going to leave me 7 minus 5, which is 2/5 as a power of the first, and then 8 minus 5, which is 3/5 as a power of the second. So the first thing times the derivative of the second is 7/5 x to the power of 2/5 minus 8/5 x to the power of 3/5 minus high d low. So the high, just write down whatever the high is, underline f prime of x, times the derivative of the low. So the derivative of the low is 1/5 x, then 1/5 minus 1 is negative 4/5. You can do it on the side if you don't know it offhand. All over low squared. So the low is x to the 1/5 squared. 7/5 times, then you add the exponents, that's going to be 3/5 minus 8/5, and then add the exponents, that's going to be 4/5 minus, and I'll put this in parentheses so I can fix the signs if I need to. Getting in the house from the other side, that's going to be 1/5 x, then we've got 7 minus 4 is 3/5 and then you got negative 1/5 x. 8 minus 4 is 4/5 because the denominator is already the same, over x squared x to the 1/5 times x to the 1/5. Simplify it again. I'm only just really going to work with that negative outside, so I'm just rewriting everything, and I'm going to get that negative inside the parentheses, so it's going to be negative 1/5 x to 3/5 plus 1/5 x to 4/5 all over. And then what does it mean to square those? It's just to add the exponents, so it's going to be 2 over 5. Alright, let's combine like terms. So you see there's something with 3/5 there, something with 3/5 there. So you got 7/5 minus 1/5 because they're the same denominator, you can just subtract, so it's 6/5. Then you got 4 over 5 and 4 over 5. You got negative 8 plus 1, which is negative 7 over 5, all over x to the 2/5. Alright, look, I can factor out x to the 2/5 so I can cancel the bottom. So if I factor x to the 2/5, remember when I add the exponents, it has to give me 3/5, so that has to be 1/5 minus 7 over 5x, and this needs to give me 4/5 when I add them, so it's going to be 2/5 all over x to the 2/5. Now what do? I cancel those out, so leaving 6 over 5, and now I'm just going to write it like this: 6 over 5 1/5 minus 7 over 5. You can see they have the same denominator, so you can put them over the same denominator, and they also have x to the 1/5 in common, so I'm also going to take that out. So if I have x to the 1/5, I'm just going to leave 6, because that's going to be that, minus 7x, and then that plus that has to give me 2, so it's 1/5. And that's pretty much it. Okay, so I'm just going to put the radicals back in, so it's going to be x to the 1/5 is 5th root of x, 6 minus 7, 5th root of x, all over 5. And that's it. So that's how you do the quotient rule. Just a quick note, if you forget the quotient rule, you could always make it into a product rule. Just make sure you ask me in class and I'll show you. But it is very worthwhile to remember the quotient rule.